Graph the inequality in two variables. We will do parts A and B, starting with part A. The first thing we want to do when graphing an inequality in two variables is to graph the related equation. So we will temporarily change this less than symbol to an equals symbol while we focus on graphing the line. However, because this is a strict inequality, it's a strictly less than instead of a less than or equal to, we are going to draw a dashed line. So we're going to graph the line 2x minus y equals 5. And to do this, we should start by solving it for y and putting it in slope-intercept form. I get y equals 2x minus 5 after solving for y, which means that we have a slope of 2, which I'll write as positive 2 over 1. And we have a y-intercept of negative 5, which I will write as the ordered pair 0, negative 5. Okay, so let's now draw our line. We're going to draw a dashed line starting at the point 0, negative 5, and with a slope of positive 2, so I'm going right 1 up 2, right 1 up 2, right 1 up 2. So here's my line. I'm going to extend it, and I'm going to put arrowheads on it. And now I'm ready to start thinking about which side of this line I need to shade. So I'm going to choose a test point to do this. Let's pick the test point 0, 0, since when your line doesn't pass through the origin, that's usually the easiest point to use. You can pick any point that's not on the line, but 0, 0 is especially easy to do computations with. Okay, so I'm going to move this and come back to the computations now. Plugging 0, 0 in for my x and y, this time in the inequality, not in the equation. 2x minus y is less than 5. If I plug in 0 for x and 0 for y, this gives me the statement 0 is less than 5, which I know is a true statement. And because it's a true statement, I know that I want to shade toward my test point or toward 0, 0. So bringing back my graph now, I'm going to fill in this region that goes toward my test point. And this is my final graph. Going on to our next problem, we're going to start the same way. We will again start by changing the inequality to an equation. This time I'm going to draw a solid line. Because it's an inclusive inequality, a greater than or equal to, instead of a strictly greater than. So I have the equation x equals 3y. If I divide both sides by 3, then I get y equals x over 3, which is the same as y equals 1/3 x And that's just like saying y equals 1/3 x plus 0. Of course, we don't really have to write the plus 0, but just to see how it is we know that the y-intercept is equal to 0, I will fill it in this time. So a y-intercept of 0 is like saying that it passes through the origin. So at this point, I am ready to bring my graph back over. And start to draw, this time with a solid line, a line that passes through the origin and has a slope of positive 1/3, which means I'm going right 3 and up 1 every time I draw a point. Now I'll extend this line in both directions and add the arrowheads. And now I need to decide again which side of this line to shade. To do that, I need a test point. I can't use 0, 0 this time because this line does pass through the origin. So I'll just choose this point here, which is very clearly not on the line. This is the point 0, 4. And I'm going to use 0, 4 as my test point. So I'll plug in 0 for x and 4 for y in the inequality. X is greater than or equal to 3y. 0 for x, 4 for y gives me 0 is greater than or equal to 12, which we know is a false statement. Because this is false, I'm going to shade away from my test point. So bringing this graph back over, I will fill in the region that's on the opposite side of the line from the test point that I chose. And there we have our graph.